baby KJ was in the news recently. This is a 11-month-old infant, genetic disorder and this was a very rare mutation in the genome of this baby. Okay, so it's like a one-of-a-kind thing. It wasn't a disease that was widely held, so there was no existing FDA-approved therapeutic for this baby. And the disease basically breaks a protein. It's kind of like how my dad didn't have insulin.
Yeah.
In this case, it's not like you don't have it. You have it, but it's broken. And that's because there's one letter of DNA that's wrong. There's a C, or ATCG, there's a C that's supposed to be a T. And it's a C in this baby, okay? And as a result, it's not gonna make this enzyme that when it eats food, okay, it breaks the food down in certain things such that there's gonna be an accumulation of ammonia. And as you accumulate ammonia, you get brain damage, all this bad stuff happens, and it's a death sentence. So what they did, and this is an 11-month-old baby, so they started this work, I think 11 months ago. They designed a CRISPR editor that targeted that exact spot in that baby's genome. Remember, everybody's genome is a little bit different. But because with CRISPR, remember I told you, you get to put the exact sequence that you want to go make a cut in. And this CRISPR editor was designed to go to that sequence and turn a C into a T. Okay? And a couple things were special about this disease. It's primarily a disease of the liver. Mm-hmm. That's the easiest place today to get editors to show up. You don't need to change every cell because the baby only needs to make enough of this stuff to break down some of the food and not accumulate ammonia. So they were able to add this editor, edit about 10 to 20% of the genomes of the cells in the baby's liver. And then now, as the baby grows, the ones that are right, the C's that got turned into T's, are going to make more copies that are correct. That's why you do it when baby's little, and it's working. That's an N of 1 drug developed in 11 months. That was like a new regulatory paradigm, and like, knock on wood, like could be curative for what would have been a death sentence.
Wow.
Okay, and that happened like last month. Wow. Okay, so that's just some of the stuff I would highlight. Like today, there's these openings around disease. Okay, where I think particularly for these like genetic diseases, these technologies are important. Since human insulin, half of your therapeutics today are made with biotechnology. Back then, that was the first one. All right.